Hi everyone, in this video we'll take another set of functions in math module. The first one is reduce Euclidean norm. The second one is reduce log sum exponential function. And the third one is Rint function, round function. And the last one is reciprocal square root function. Let's get started. Let's first take reduce Euclidean norm function. This function computes the Euclidean norm of elements across dimensions of a tensor. Let's say we have this tensor, one-dimensional tensor with just 3 elements in it, 1, 4, and 7. When we apply reduce Euclidean norm on this tensor, as you know, this tensor just has one dimension, so we will apply reduce Euclidean norm on this dimension. This function will compute square root of some of the squares of the elements in this dimension. As you can see here, this tensor has just one dimension, and this dimension has the following elements: 1, 4, and 7. So 1 squared plus 4 squared plus 7 squared, and we will take square root on the final result. Now let's talk about the arguments of reduce Euclidean norm function. The first argument is input tensor. The input tensor should have numeric type. The second argument is axis. We can specify the dimensions that we want to reduce by using axis argument. If axis argument equal to none, which is the default value, so reduce Euclidean norm function will reduce all dimensions of a tensor. And axis argument values should be in this range between minus rank of input tensor to rank of input tensor. Third argument is keep dimensions. If it is true, reduce Euclidean norm function will return reduced dimensions with length 1. Last argument is name, which is a name for the operation. It is optional argument. The output tensor has the same data type as the input tensor. Now let's say we have this tensor, two-dimensional tensor, and the data type of this tensor is float 16, and we want to apply reduce Euclidean distance norm on the column dimension of this tensor. How to do that? First, we will type tf.math.reduce underscore Euclidean norm, open parenthesis. Here we will put the input tensor x. And after that, we will set the value of axis, which is 1 column axis or column dimension. Now let's run this cell. And here's the results. As you can see here, the data type of this tensor is float 16. The first element in the output tensor, which is 6.7, it is the square root of 2 squared plus 5 squared plus 4 squared. And the second element in the output tensor, which is 11.53, it is just the square root of 4 squared plus 6 squared plus 9 squared. Now let's apply reduce Euclidean norm function on the first dimension or on the row dimension. So we will make axis argument equal to 0. Now let's run this cell. And here's the output tensor, which is a one-dimensional tensor with 3 elements, and the data type of this tensor is a float 16 as the data type of the input tensor. The first element in the output tensor, which is 4.473, it is just the square root of 2 squared plus 4 squared. And the second element in the output tensor, which is 7.8, it is just square root of 5 squared plus 6 squared. And the last element in the output tensor, which is 9.8, it is square root of 4 squared plus 9 squared. Now let's say the data type of the input tensor is integer 16. What is the result will be? As you can see here, here is the result. The data type of the output same as the data type of the input, which is integer 16. So the elements in the output tensor, they are just integers. Now if we want to reduce all dimensions, just make axis argument equal to none. And here's the result. To just scale a value, which is equal to 13.35. Now let's take the second function, which is reduced log sum exponential function. Let's say we have this tensor with just 3 elements, 1, 4, and 7. You should know that exponential to the power 1 equal to 2.71. The first thing that reduced log sum exponential function will do is take an exponential, as you can see here, to each elements in this one-dimensional tensor. So exponential to the power 1, exponential to the power 2, and lastly exponential to the power 7. So now we have this new tensor. The second step is taking log to the sum of all these elements in this new tensor. And the final result is 7.05. Here is the arguments. The first argument in reduced log sum exponential function is input tensor. Input tensor should have numeric type. The second argument is axis. And the third one is keep dimensions, and the last one is name. Now let's apply reduced log sum exponential on tensor x. So let's type tf.math.reduce _ log sum exponential, open a parenthesis. Here we will put the input tensor, which is x, and the axis that we want to reduce. Let's say we want to reduce column dimension, so we will put 1 here. Now let's run this. And here's the result. As you can see here, the output tensor, the data type of the output tensor, same as the data type of the input tensor. Let's make our previous steps to be sure. Firstly, we will take exponential for each element in tensor x. So we will type tf.math.exponential, open a parenthesis, and here is the output tensor. Let's name it x new. Now we will use reduce sum function. So x new equal to tf.reduce _ sum. And this function will take the input tensor and the axis that we want to reduce, or the dimension that we want to reduce, which is in this case column dimension. So we will set axis to 1. Let's see the result. As you can see here, here is the output of reduce sum function, which is 2 values, or tensor, one-dimensional tensor with 2 elements. Now we will apply log function on these 2 elements. So x new equal to tf.math.log, open a parenthesis, and here we will put the input tensor x new. Let's see the results. X new. And as you can see, here is the result, which is same as the result that we obtained by using reduced log sum exponential function. Here is the first element and the second element. Now let's take Rint function. This function will return element-wise integer clauses to input tensor. Let's say we have this tensor, input tensor, one-dimensional input tensor with just 2 elements, 0.9, 0.1. If we apply Rint function on this, tensor, the result will be like this. The first element, which is 0.9, it is close to 1. So the result is 1. And the second element, which is 0.1, it is close to 0. So the result is 0. If the number is midway between two representable values, as in this case, the even representable is chosen. As you can see here, 1.5 will be 2 and 2.5 will be 2 as well. There are just two arguments in this function x, which is the input tensor, which must be one of the following types, as you can see here. And the second argument is name. And the data type of the output tensor, same as the data type of the input tensor. Now let's say we have this tensor, tensor x, and here is the elements in this tensor, 2.8, 5.2, 4.5, etc. And the data type of this tensor is tf.float32. So now let's apply rent function on tensor x. So let's type tf.math.rent, open parenthesis x. Let's run this cell. And here is the result, 2.8 close to 3, and 5.2 close to 5, 4.5 in the midway, so we will take the even number, which is 4, 4.6 close to 5, 6.8 close to 7, and the last one, 9.9 close to 10. Now let's take round function. This function rounds the values of a tensor to the nearest integer element-wise. So it works like rent function. Here is the arguments of this function x, which is the input tensor, which must be one of the following data type. And the second argument is name. And the output tensor has same shape and type as input tensor. Now let's use round function, which is work same as rent function. So we will type round here. And here's the results. Finally, we will take reciprocal square root function. This function will compute reciprocal of square root of input tensor element-wise. Let's say we have this input tensor, which has two elements, 2 and 5. If we apply reciprocal square root on this tensor, the result will be like this. So we will take reciprocal square root of element 2, and we will take reciprocal square root of element 5. There are two arguments in this function. The first argument, x, which is the input tensor, which must be one of the following data types, as you can see here. And the second argument, name, which is a name for the operation. This function will return a tensor with the same shape and data type as the input tensor x. Now let's say we have this tensor, tensor x, and the data type of this tensor is float32. Now we will apply reciprocal square root on this tensor, or on tensor x. So let's type tf.math.reciprocal square root, open a parenthesis, and here we will put the input tensor x. And here's the results, as you can see here. The first element, it is just 1 divided by the square root of 2. And the second element, which is 1 divided by the square root of 5. And the third element here, 0.5, it is just the 1 divided by square root of 4, etc. Thanks for watching.